Transforming the parent functions can be done in several ways. One way is vertical translation, which means you're basically moving it up or down. Adding a number to your f of x is going to move that graph up because your f of x is going to increase. Similarly, if you subtract the number, it's going to move it down. Secondly, horizontal translation. This is counterintuitive. If you're subtracting a number off of your x, you're actually going to be moving the graph to the right. Why is that true? Because you need a higher x value to get back to the original graph. If this were subtracting off 2, you'd have to put a higher x in to get it back to this graph. Some students just recognize that it's the opposite movement of the sign that's seen. Similarly, if you're adding a number, it's going to move to the left. Reflecting over the x-axis is where you multiply your f of x by -1. All of your positive x's would then come down to the negative x's, and vice versa. Reflecting over the y-axis, where you multiply or you replace an x with a negative x. All of your x's now become negative x, and your y's would be the same. Vertical and horizontal translations. So in this case, instead of expanding and compressing, I like to think about, is the graph getting narrower or is it wider? And so in this particular case, where you're multiplying a number by your f of x, where a is greater than 1, that means that your f of x is going to grow faster than the original blue graph. So that means it's going to be a narrower graph. If a was between 0 and 1, it would grow slower than 1, and therefore it'd make it wider. On the horizontal dilation, you're multiplying the number by x, and if a is greater than 1, that means you're going to move through the x's quicker, which means that this graph is now going to become narrower. If it was between 0 and 1, then the graph would be wider because it's going to be moved through your x's slower. I want to just take a look at some general graphs of what this looks like and what's happening to the parent functions. If you look at the first problem, g of x equals 0.5 times the absolute value of x plus 4, I'm looking at this in terms of how to move it first, and so you're going to see that this is going to be moving 4 units to the left, and therefore it's going to look like this. And then the second part is it's 0.5, so it's not going to be rising as fast, which means that basically you're going to be making it wider than the original graph. And so I'm trying to move that wider, maybe like that. Could do it. Didn't work, but the idea is that you want to make it wider than what the original graph is. Secondly, if you were to, so I'm just going to leave that and say, hey, oh well, I'm not satisfied with that yet, so let me just redo this. So it's going to be wider by about a half, so it's going to look like that, and it's going to look like that. And so this one would then be eliminated, which means the graph would look like that. So secondly, I'd like to work with this one. This is a general parent function of a quadratic. As I can see, I'm going to be multiplying it by 2 and then subtracting 4. So I want to take the initial and I want to shrink it. So and I want to move it down 4. So I want to move that down 4. And then the second part is I want to shrink it. So to do that, I want to graph it. And this is going to get a little bit ugly here. But for the most part, we're looking at shrinking by about twice as much which looks something like this. And then again, thank you for helping me, but I don't need it anymore. And therefore, that's going to be the blue graph, purple graph. So in summary, we looked at how do you transform parent functions, and it's done in a variety of ways. And then we looked at 2 examples at the end.